Range 249, BW Finer. Cleared for takeoff.
I have never worked in a project so complex and so challenging as this one.
We're talking about record water depths here, and we're talking about a lot of new technologies.
We really pushed the envelope in a lot of disciplines, a lot of components, a lot of systems.
We've been working in deep water for more than 30 years now. Petrobras is very well prepared for these challenges.
The Cascade and Chinook project is one that we can all be proud to be part of.
"160 miles off the Louisiana coast, the FPSO, a floating production, storage, and offloading facility, sails U.S. waters for the first time. She prepares for the final test before oil and gas can begin flowing from wells deep under the seabed. If the test is successful, Petrobras, a pioneering energy company, will complete one of the most complex subsea infrastructures in the Gulf of Mexico, and the first of its kind in U.S. waters. Within the ship, and open to the sea below, a compartment stretches up 4 decks. A huge buoy is locked inside, mating the ship to the mooring system, risers, flow lines, and wells on the seafloor. Once connected, the entire subsea infrastructure can be controlled from the ship. And it's here where millions of gallons of oil and gas will flow from deep below the Earth's crust. But in the Gulf of Mexico, hurricanes are a constant threat, with wind and waves capable of toppling conventional drilling rigs attached to the seafloor, causing massive losses of equipment. To solve the problem, Petrobras turns to a system that has never been used here before, an FPSO, moored by a detachable STP buoy, a submerged turret production buoy. This is no ordinary buoy. It's over 81 feet high, nearly 45 feet wide, and weighs almost 1,200 tons, more than 500 pickup trucks. The STP buoy's unique features allow the ship to weather vane freely, turning into prevailing wind or current, reducing the stress found on stationary structures. And when a hurricane approaches, this system can be disconnected, letting the ship and crew go to safer waters.
We've simulated everything, but until you actually perform a full-scale disconnect with the 2 structures out here together, the FPSO and buoy that is, you don't really know until that moment that it really works.
And this is the crucial test.
3, 2, 1, 0.
It's a success, paving the way to begin pumping oil and gas from the Cascade and Chinook fields at the bottom of the Gulf, where this story began years ago.
It all started back in 2004 when Petrobras were partners in 3 discoveries here in the Gulf, Cascade, Chinook, and Samal.
Petrobras has been a pioneer in offshore oil and gas production for over 30 years. Always looking to the future, the company surveyed part of the Gulf of Mexico and discovered compelling evidence of substantial oil reserves in water too deep and too isolated for conventional technology at the time. With the company's long history of ultra-deep sea experience and a culture of pushing the boundaries of technology, Petrobras decided to develop 2 fields, Cascade and Chinook. They drill exploratory wells, obtaining cores to understand the underlying sediments deposited millions of years ago.
Core is the first thing that comes with a direct measurement.
The team finds new hydrocarbon-bearing sediment 17,000 feet down, part of the deepwater Wilcox trend.
The Deepwater Wilcox Trend is a largely untested region. We've never produced in these particular sands before in this area of the Gulf of Mexico.
The cores confirmed the presence of oil-bearing reservoirs at both the Cascade and Chinook fields and aid in their planning and development. But the exploratory wells are only the beginning. The wells team has to drill deeper than the company has ever attempted, nearly 9,000 feet underwater, 27,000 feet below sea level, more than 9 times the height of the world's tallest building, the Burj Khalifa. The pressure at the bottom of the wells is around 19,000 pounds per square inch, nearly 1,300 times normal atmospheric pressure. And oil temperatures down here are near 250 degrees Fahrenheit, hot enough to boil water. The decision to extract energy from these new fields wasn't easy. The company faces massive technological challenges. The Cascade and Chinook fields are among the deepest in the Gulf, beyond the reach of existing pipelines to send the oil to shore. And this far at sea, a conventional platform would be isolated, vulnerable to the Gulf's notorious storms. Every step of the way will require new thinking, innovation, and planning for every contingency. And a string of firsts that began with drilling and completing some of the deepest and most complex wells in the world. A key milestone is installing a blowout preventer, or BOP, on each well. Should anything go wrong, its job is to seal the well, preventing the uncontrolled escape of oil and gas. Lowered through the rig's moon pool, the blowout preventer begins a long 2-day journey all the way down to the seafloor. After the BOP is installed, the well is drilled and lined with up to 7 different sizes of casing, each progressively smaller until it reaches the reservoir. The next stage is completing the wells.
We're gonna do a 3 intervals frac pack in just 1 trip of the service tools.
It's a system commonly used in shallower wells, but never tried deeper than 12,000 feet.
We're going in deeper waters with more difficult formations and reservoirs to develop.
In an industry first, Petrobras completes the Cascade and Chinook wells at over twice that depth, 27,000 feet. While the wells team is hard at work, development of the Cascade and Chinook fields is moving forward. In Houston, Texas, the core team initiates a series of ambitious projects around the world. And they must manage them simultaneously across many time zones and languages, ensuring the completion of each one on time.
The project team is the greatest team you can think of.
Working tirelessly behind the scenes, coordinating and managing the project. Collaborating with partners, vendors, and Petrobras headquarters in Brazil.
People from 21 different countries with different cultures.
Orchestrating the efforts of suppliers worldwide. New operations in the Gulf must meet the company's rigorous standards of safety.
Safety is a core value in the Petrobras culture, and we use safety management as a strategy for our company growth.
While cooperating with U.S. regulators to create new laws for this pioneering project. Petrobras forged teams of multidisciplinary experts, wells, reservoirs, facilities, project coordination, HSE, subsea infrastructure, shuttles, and FPSO. Dedicated, committed, and passionate. Innovating, problem-solving, creating new solutions, then coordinating and integrating their results. Pioneering new ways to harvest energy from the deep sea, where oil and gas will flow from the wells through a system of flow lines, up to the massive STP buoy, and then into the FPSO, where the production fluid will be processed and stored. To get the oil to shore, Petrobras brought in 2 purpose-built shuttle tankers, the first of their kind in the Gulf. Built in Philadelphia, converted in Charleston, and manned by U.S. crews, each is 600 feet long and can transport 330,000 barrels of product. These shuttle tankers set the stage for a new era of energy production from wells ever farther from shore. Over 160 miles out in the Gulf, the subsea team is building the subsea infrastructure, some 8,100 feet below. They'll need to install two 12-mile flow lines from Chinook and two 5-mile flow lines from Cascade. The seafloor in the Chinook field is marked by deep mega furrows, some 30 feet deep and more than 170 feet across, that would leave flow lines vulnerable to harmonic vibrations caused by currents. If the oil, gas, and water mixture inside the pipes were to stop flowing for any period of time, the extreme cold of the deep waters could freeze the mixture. To prevent this, the 9-inch line that carries oil and gas is nestled inside an outer 14-inch protective pipe, filled with newly designed insulating nanogel foam technology. To reduce vibration, helical strakes are welded onto over 9 miles of the pipe. On board the deepwater construction vessel Harima Balder, this special pipe-and-pipe flow line is fed onto the seabed. It's the longest run of pipe-and-pipe flow line ever installed over furrowed terrain. With the flow lines in place on the bottom, the subsea team tackles the next critical phase of the project: installing the 5 risers that will deliver hydrocarbons from the sea floor up to the FPSO. These will be the deepest production risers in the world. To accommodate natural movement of the FPSO, the risers are a hybrid design. A vertical steel pipe riser tower extends from the seafloor up to a supporting buoyancy can, just 700 feet below sea level. A flexible pipe suspended in a catenary then connects to the top of the vertical riser tower to the STP buoy.
The installation, of course, is challenging as well. We're installing these risers in 8,000 feet water depth. That in itself is a big challenge. We have 3 vessels out here in the field and all their activities need to be carefully coordinated.
On shore, the command team manages the complicated operations for this installation. In total, there are 4 campaigns: installing suction piles, building the vertical risers complete with their buoyancy cans, connecting the flexible jumpers, and then installing the riser base jumpers, the final connection between the flow lines and the riser. Now, the deepest production risers in the world and the first freestanding hybrid risers in the Gulf of Mexico are in place. Meanwhile, other elements in the subsea infrastructure are being installed: manifolds, trees, and pump bases. All were completely assembled on dry land and rigorously tested, then lowered to the seafloor and connected in carefully choreographed operations with multiple ships, skilled crew, and precisely controlled ROVs.
Well, over time, the thousands of pounds of pressure inside the well will decrease, and the oil and gas will need to be boosted along the many miles of seafloor to get it up to the surface.
Pumps on wellheads aren't new, but for the first time, they'll be installed horizontally outside the well on the seabed, easily accessible for service without shutting down production. A pump base is installed in Cascade and another one in Chinook, each with 2 pump cartridges. To monitor and control the sophisticated hardware on the seafloor, it takes electrical and hydraulic power and fiber optics, all delivered through umbilicals.
Needed 3 years of research, design, and prototype tests.
With new applications of carbon fiber rods, super duplex tubing technology, and polymer construction. The static umbilicals will lay on the bottom, and dynamic umbilicals will connect to the central hub of the turret buoy far above the seafloor. Because of the umbilical's unique size and specifications, standard manufacturing equipment required custom modification. In all, 7 separate umbilicals total over 40 miles. The Chinook power umbilical, at nearly 14 miles, is one of the longest in the world. Fully assembled with terminating hardware, this umbilical weighs over 1,000 tons, nearly twice the weight of a fully loaded A380 Airbus. Meanwhile, in Batam, Indonesia, work is coming to an end on the world's largest turret buoy. It's loaded onto a cargo ship, embarking on a 45-day journey around the world and through the Panama Canal. Finally, the buoy is on site above the Cascade and Chinook fields. Aboard the Harima Balder, anticipation is high to complete this vital installation. Even if all goes perfectly, it will take 4 days to install the buoy, with every step carefully calculated and planned. It can all go wrong with a sudden change in the weather. The sea fastenings are cut, setting the operation in motion. The buoy is lifted from the transport vessel. It must remain at this most vulnerable location until other key steps are complete. The clump weight is sent to the bottom. At 330 tons, it will hold the buoy 328 feet below the surface. Now, surface buoys are attached that will mark the STP buoy's location, and the turret buoy is lowered. Remotely operated vehicles become the team's eyes and hands, controlling a series of valves to manage the buoy's descent. A total of 11 mooring lines will keep the buoy safe below the waves during storms. An integral monitoring system constantly reports the status of the buoy and each mooring line. The STP buoy will be the connection point for the umbilicals running from the seafloor to the FPSO. But with the processing vessel still months away, Petrobras engineers devise an innovative way to hang the umbilicals on the STP turret buoy.
We decided to pull in the control umbilicals directly to the submerged turret buoy.
Ready for the final connection upon the arrival of the FPSO. A unique subsea winch rests on top of the buoy, monitored and controlled by ROVs 150 feet below. It pulls the umbilicals through the buoy and clamps them in place. It's the first ever diverless winch-attached ROV umbilical pull-in system, and it works without a hitch. The umbilicals are in place, ready to be connected to the FPSO when she arrives, saving valuable time in the final stages of the project. The FPSO enters the Gulf of Mexico, headed for her mooring above the Cascade and Chinook fields.
It's the first FPSO in U.S. waters, the deepest production facility in the world.
Nearing the end of a long journey, the ship began as an oil tanker. At shipyards in China and Singapore, it was transformed into a powerhouse hydrocarbon production facility, capable of processing 16 million cubic feet of gas and 80,000 barrels of oil a day. Converting the ship to include the many necessary processing modules was no easy task. But just as critical, wave tank testing of the ship's design made sure the vessel could safely withstand the wind, waves, and currents of the deep Gulf. The FPSO sailed with the confidence of handling a 100-year storm. Work continued even during the 53-day journey to the Gulf. On board all its vessels, on land and under the sea, Petrobras' commitment to safety throughout this project and every project is without parallel. A remarkable 3 million man-hours, without one incident causing a worker to miss his or her shift. The FPSO pulls the STP buoy into its mating cone inside the vessel. The locking arms click into place, and the FPSO becomes the deepest production unit in the world, the first in the U.S. Gulf of Mexico, and a crowning moment of the Cascade and Chinook project. The crew prepares to open valves far below on the seafloor. Years of innovation are about to become a reality. Switches are flipped.
We're going to open a production wing. Roger that, opening FLRD.
Gauges come to life. Engineers wait for signs that oil and gas is flowing and that all systems are working perfectly.
It's open at step 3, well it's open, good job.
First oil. Marking a milestone in Petrobras' pioneering exploration of new energy frontiers.